Hello and welcome to my presentation on the subject of using spreadsheets for electrical calculations. My name is James Curnow and I'm an electrical engineer, and this is a pre-recorded short webinar on the subject of using spreadsheets for electrical calculations, and specifically I'm going to be talking about using spreadsheets to calculate maximum demand and diversity for a simple installation. Now I'm sure this may be a familiar subject to many members. The purpose of this is to share tips that I have found in my experience, and if this is a subject that is of interest and if anybody would like to hear more about this subject, please let us know. So there are a few benefits of using a spreadsheet to calculate maximum demand, and the first one is that I can save it to my computer and keep for my records for the future. I can add it to an electrical certificate if I really wanted to, but just to have that record there I find really helpful. Also, I can send the calculations if I need to, and most recipients should be able to open an Excel file. Also, if I save it in the cloud, I can access the document on my smartphone when I'm on site or if I'm in a meeting. And I can easily update the spreadsheet to keep track of any changes in the design, which allows me to check if any additional loads will cause a problem. So if you've ever been in the situation where a customer has asked if they can add an additional load and you need to check that isn't going to cause an issue with your maximum demand, having that available on the spreadsheet, you can access it on your phone or on your laptop. It's really helpful just to see if there's going to be an issue there. Now, the reasons for calculating maximum demand is the sum of all connected loads, but we can give consideration to allowable diversity factors. Now, there are a few different ways of doing this. There are different diversity factors for different types of installation, and they are available in the on-site guide. It is important to take care when calculating maximum demand to ensure that the electricity supply is sufficient for the electrical load, and this is particularly important when requesting a new electricity supply for an installation. If the demand is underestimated, the supply may be not large enough, or if it is overestimated, the cost of the installation will be increased. Now, when requesting a new electricity connection, the DNO will ask for the maximum demand in kVA. They won't ask you for it in amps, and typically they won't tell you how much you can have. They will need you to calculate it for them. So if you're wondering whether to use amps, kilowatts or kVA, well, the maximum demand can be calculated in amps or watts. However, as I mentioned a moment ago, when requesting a new electricity supply, the DNO will ask for the maximum demand in kVA. So when you start out designing the installation, the design current is typically used for each circuit. So you would start off in amps. If the installation uses electric heating, it may be necessary to know the heating load in kilowatts. So this is a simple spreadsheet that I created for a domestic installation. Now the thing with Excel is you can make it look however you want. You can display the information in whichever way makes sense. So what I've done here is in column A, I've listed all the circuit numbers. In column B, I've listed the description of the circuits. In column C, I've added the power rating in watts for the circuits that I know what the rating is. So what I want to do now is in column D, I want to find my design current. And so Excel can do this for us. So what I do here is highlight the cell where I want the answer to go. I type equals, then I highlight the cell, and then I press / for divide, and then we want to divide that by the voltage, which is 230 volts. Press enter, and the design current will be calculated automatically. So what I want to do now is I want to repeat that process for the remaining circuits that I know the load in watts. So just do that again. Okay, so that's calculated the design current for those circuits. Now, for the other circuits where I don't know what the rating in watts is going to be, what I tend to do is just to use the rating of the protected device that I've selected. So, as these circuits are all ring socket circuits, I'm going to put 32 amps in each of those. So you see that's totaled that at the bottom there. Now, that's the maximum demand for all loads added up together. So 169 amps, which is quite a lot. So what we want to do is we want to apply diversity to each of those circuits. And the method that I've used in this example is by using the 100% of the largest load and 40% of the remaining loads, which is for circuits that are in accordance with Appendix H in the on-site guide for simple domestic installations, basically. And with this, where the cooker is the largest load, we still use the same method of calculating diversity for that cook circuit, which is 10%, the first 10 amps plus 30% of the remainder plus 5 amps if there's a socket in the cooker outlet. Now, for the purposes of this, I've assumed that there isn't a socket in the cooker outlet. So what I want is the first 10 amps plus 30% of the remainder. And again, we can get Excel to do this for us. So what I'll do here is I just highlight the cell where I want the answer to go. I'll type equals, so 10 for the first 10 amps plus 30 multiplied by, and then in brackets we're going to put 52.17 minus 10, and then close brackets, and then we divide by 100. So what we have there is, by having the load in amps 52.17 minus 10 gives us the remainder. By dividing it by 100 and then multiplying it by 30 gives us 30% of the remainder, and then of course adding that 10 that's the first 10 amps. So if I press enter, so that gives me 22.65 amps. Now for the remaining circuits, what I'm going to do is all I want is 40% of the load for each circuit. So the way I do this, just to keep it nice and simple, is I type equals, then I highlight the relevant cell over here, and then I press the asterisk for multiply, and then type 0.4. So multiplying it by 0.4 obviously will give us 40%. If I press enter, and that gives us 5.22. So where I want to repeat that for all the remaining circuits, all I do is, if I hover in the corner here, I'll get the little plus sign, press the left button and drag and let go, and that applies that. And so what you'll see, if you double click, you'll see that has applied the formula to the relevant cell over here. Okay, so that gives us the maximum demand after diversity of 69.66 amps, which obviously is much better. So what I want to do now is I want to work out what that is in kVA. So what I'm going to do is, I've shown the formula here for calculating, for converting amps into kVA. So all I'm going to do is I'm going to highlight the cell where I want the answer to go, and I'm going to type equals. I'm going to highlight the cell where I've got the current, and then I'm going to press the asterisk for multiply. I'm going to times that by 230, and then / for divide by 1000. So that gives us 16.02 kVA. So that is how I calculate maximum demand for a simple installation using Excel. So this is another example that I've created, but this time I've taken away the electric cooker. I've assumed that we're going to have a gas cooker instead, and this time the largest load is going to be an electric shower, which is 9.2 kilowatts, which calculates to 40 amps. So we're going to use 100% of that, as it's the largest load, and then 40% of the remaining loads. So you can see the difference that makes. Obviously the maximum demand this time after diversity is 87.01 amps, and that calculates to 20.02 kVA. So just points out there just the difference that makes in the maximum demand, having that change in circuit. So just to summarise the calculations that I used in the examples, so we have the calculation for design current for the 12 kilowatt cooker circuit. We have the example of calculating diversity for a cooker circuit without a socket in the cooker switch. So that's for the first 10 amps plus 30% of the remainder. And then for calculating the percentage diversity for 100% of the largest load and 40% of the remaining loads. So here I've got some tips when calculating maximum demand. So first of all, I like to use the design current for circuits where I know what the actual load is in watts. For circuits where I don't know what the load will be, for example on a ring socket circuit, I use the rating of the protector device. I always try and keep track of additional loads, so any changes in the project that you're working on, just keep track of those so that make sure that you are within the maximum demand. Remember that adding circuits will increase the maximum demand, so obviously bear that in mind when adding additional circuits later on. And my last tip is to read the on-site guide for information on the different diversity factors that apply to different circuits and also different types of installation as well. Thank you very much for watching. We hope that you found this presentation interesting. For updates on future events, you can keep in touch with us in the following ways. You can join our IT community, you can follow us on Twitter @IET Oxford, or you can follow us on Facebook as well.